Hello everyone, in this video we're going to be talking about a way that you can solve linear systems, especially 3x3s, in a very quick way and efficient way. The rule is called Cramer's rule, so this is the name of it, Cramer's rule. It depends on the determinant of matrices. We're going to be using determinants. So it has only one condition, which is the determinant of the left side is not zero. For example, or let's actually look at the coefficients of x, y, and z, the variables. So we have 1, and then we have 2, and we have for z 0 because we don't have z in the first row. And then we have 2, 1, and 1. So 2, 1, 1, and then 4, negative 2, and then 2, right? So you can do this quick, okay? So if you do it, I think we get like, I don't know, maybe 4 and then minus like 0 something. You can actually do the calculation. I'm pretty sure that this is actually not 0. We're going to be calculating this determinant later on anyways. So the condition is that the left side of the equation, the matrix that you get, we know this is a linear system, AX is equal to B. So the matrix A, the determinant of A is not 0. Once we're sure that it's not 0, we can actually use the rule itself. Okay, so as I did here, so I'm gonna do the same thing again. So I'm gonna call it the matrix A. So the determinant of A, as we said, the same thing. So 1, 2, 0, 2, 1, 1, for negative 2 and 2. Okay. So before actually calculating the determinant here, we're gonna be needing to find the determinant of 3 other matrices. Okay. So we can actually call them A sub x. So this is just a name. It's not a differentiation. It will not make sense. It's not differentiation, okay? It's just an index. So A sub x, what that would be? Okay, so this original matrix, you're gonna be writing it down the same way, right? Except for the row that is responsible for x, okay? So this is the coefficients of x, right? So we're gonna be actually replacing these with the numbers on the other side, with the numbers in matrix B. So 5, 7, and 6. Okay, 5, 7, and 6. Okay, so this is A sub x, the determinant of that. And then, of course, we're going to have A sub y. Okay, again, it's the original determinant. Okay, so 0, 1, 2. So the same things in x and z column. So 1, 2, 4. Let's actually draw a line so that we don't mix it. Okay. And then for the y part, you're going to be actually writing the matrix that you replace for x. This time you put this in y, so 5, 7, and 6. Okay? And of course, you're going to be doing this also for A sub z. We can write it here. A sub z, the determinant of A sub z. Okay? So that would be actually as we said, the same thing for x and y. So 1, 2, 4, 2, 1, negative 2. And then for the third column, as we said, we put it first for x, second for y, and then, of course, third for z. So 5, 7, and 6. Okay? So before I actually calculate these determinants, which should be a piece of cakes, it should be a piece of cake. Because if you don't know what are determinants, this is not the video for you. Go ahead, watch a determinant video. I actually do have videos on them. Anyways, so without doing any other things, you can immediately say that the value of x, the variable x, would be this. Okay, it would be the determinant A, the result that we're gonna get from here. A sub x above it, okay, so it's gonna be this divided by that, and then we're gonna actually calculate at the end. So y also would be A sub y, okay, so this one over the determinant of a. So as you can see, the determinant of a is repeated every time, and also it's in a denominator of a fraction. That's why we needed it to be not 0, okay? So z also is going to be a sub z divided by the determinant of a, okay? So as you can see, if we can actually calculate these, okay? So there are just numbers, we can plug them in and you get the result. I know this is taking too long. It's only because I'm trying to explain. Because if you're fast and quick with calculating determinants, it will take 3 minutes, okay? Anyways, so the determinant for a would be, you use 1, right? And then you multiply these two, so you get 2. And then you put a minus, and then 1 times negative 2, so negative with a negative, it becomes a plus. And then you choose this, so you put a minus at the second part, like this, okay? So minus 2, and then you cover the corresponding row and column, so you get 2 times 2, which is 4, and then minus 1 times 4, which is, this will be 0, and then plus 0, because the third one that we're using is 0, so it doesn't even matter. So I think the one that we calculated above was also true, so this is 4, and then this all becomes 0, okay? So this is just basically 4. Okay, for a sub x, let's see, again the same step, so 5, you write 5, and then 1 times 2 is 2, and then 1 times negative 2 with a negative is 2, so basically we get what? 2 plus 2 here, okay? And then negative 2, and then the same thing, cover the row and the column, so 7 times 2 is 14, right? And then 1 times 6 is negative 6, because of the rule. And then the other one is 0 because the third element is 0. Anyways, so this would be actually 20. So this would be 20, okay? Minus this would be 8, and then times 2, so 16. So basically again 4. Wow. Okay, so both are 4. Anyways, so let's continue, but this time quicker. So 4 times 2, 14. 14 minus 6, so that would be 8, okay? And then for the second part, don't forget about the minus. So we have 5, and then 2 times 2 is 4. Again, it's the same cofactor, although we don't need to mention it here. So it would be 4 minus 4 again, or let's say just 0. So a sub y, the determinant of that is 8, okay? So the only remaining part is a sub z. This one doesn't have a 0, so it's going to be a little bit tedious, okay? So we have 1 times 6, okay, and then plus 14, so this would be actually 20, and then minus 2, right? And then 2 times 6, 12, minus 14, so negative 2, like this. And this time we need the third one, so we have 5, okay? 2 times, so negative 4, and then this is also negative 4, okay? So let's see, do we get 20, and then plus 4, actually. And then this would be actually, let me see, did we actually make a mistake or not? All right, we'll see. So as we said, this becomes a positive 4, yeah, and this will become a negative 8, right? So, all right, so I think this becomes 24. Okay. All right, so we have calculated the determinants, right? So a sub x was actually, what was it? It was 4, right? So 4, and then the determinant itself was 4, right? So 4 over 4 is 1. So x, the value of x is 1, right? And then for y, a sub y is actually 8, okay? We calculated this. And then again, a is 4. So 8 over 4 gives you 2. So y is 2. And then lastly, a sub z was 24, right? Above what? Above 4, right? So that's supposed to give us 6, but I think if you put it here, that would be wrong. So there should be a mistake here. I'm not sure. Well, let's see. This is the original matrix, right? We'll replace that with 5, 7, 6. So we have 1 times 6. This is 6, right? Plus, we said plus 14, that gave us 20. And then for this one, we did this 12 minus 14 gave us -2. So -2 with -2 gave us 4. So yeah. And then we got 24, right? And then lastly, we did this, right? That gave us what? It actually gave us, I don't know, like there has to be like, I think the last part gives us -12. So this gives us in total 12. So if this is 12, right? The whole thing would be 3. Okay? So we can check if this is actually true. So for example, here, if x is 1, we get 2. And then this is 2, so this is total 4. Z is 3, so yeah. So it all gives us 7. Yeah, once you get quicker with this, you can, as I said, you can do it in 3 or 4 minutes. This took too long because I just tried to explain it, okay? See you in the next one.